All right, this is going to be a review of problem 2B12, fluid flow in a network of tubes. So we know the pressure at A and the pressure at B, so we need to find the flow through this network based on those pressures. And as you can see, it's a modified pressure function, so we're going to be working with modified pressure equations. So let's get into it. Go to 2.3-21. It's the Hagen-Poiseuille equation. It's basically a pipe flow equation. Yeah. Okay. So here's the Hagen-Poiseuille equation. Just use that. Yeah. We've done pipe flow equations throughout this whole chapter. So yeah, you know how to do that. It's pretty beat in at this point. So yeah, mass flows from high to low pressure zones. So these higher points are going to be low pressure points, and these 2, 1, and 4 are going to be low pressure as well because they're connected more directly to the high pressure area than the reverse direction. Obviously, just think about it logically. The air in the pipes is going to flow towards the direction where it's all generally flowing. So you can kind of just like intuitively know where these arrows are going to be. Yeah, like it's not the air is not going to go down. It's not going to go in the reverse direction. It's not going to go down here. It's not going to go. It's just going to, the arrows are going to go this way. Just kind of try to think about it intuitively, what makes the most sense. And the pressure goes up when the height increases because pressure is a function of the height of the fluid, with the equation rho GH. So yeah, the higher the fluid is, the lower pressure. Yeah. Also, assuming general flow direction is from A to B, that takes care of the horizontal direction. Yeah, at first I was kind of confused. Does the air go down? Does it go up? But just think about it intuitively. What direction it's going to go? All the pipes are going to go in, or the air is going to go generally in this direction. So up into the right, I guess. Just think about that intuitively. From there, we do a point mass balance at each of the vertices. We have 6 unknowns, pressures 1 to 6, and that's, you can see it in the just 1, 2, 3, 4, 5, 6, 4. Yeah, and we can't do balances at the A and B points, and that's because to know the air velocity at like through this point, you would need the pressure at the end of this point too, and you would need the pressure at the end of this point. So we can't do a balance at that point because we don't know those pressures. It's not given. So yeah, that's why we only have 6 equations and not 8. Yeah, so basically now I just do the equations. It's pretty simple. You just the flow rate of all the in pipes is going to be equal to the flow rate out of all the out pipes. So the mass flow rate is this equation, and so the point balance is at 0.3 is just going to be this pressure A minus pressure 3. All this equals pressure 3 minus pressure 6 plus pressure 3 minus pressure 5. So basically we're just going to go to that. So yeah, at point 1, it's going to be PA minus P1. Where's point 1? PA minus P1, that's the inlet. And then it's going to be P1 minus P5 plus P1 minus P4. And that's what you'll see in this equation here. P1 minus P5, P1 minus P4. It's the inlet minus the outlet pressures. And then And yeah, all these terms. So basically you could just divide out all these terms because they're going to be the same throughout the whole system. And that's what I do. And then I basically do that for all the points. So you can go through and check that if you want, but it's pretty simple as far as how you do that. So now with these equations, we have 6 equations, 6 unknowns, 6 equations, which would be, all these equations, and then the unknowns would be modified pressure P1 through 6. So we can solve that with system of equations, basically. Through inverse matrix multiplication, I isolate each unknown, basically. And how I do that is I do inverse matrix multiplication. Does that make sense? Okay, yeah. So yeah, inverse matrix multiplication is basically just, and you get this crap, basically. And you multiply the inverse matrix times so yeah, that makes sense. So yeah, so you get the each of the P1 through P6 in terms of PA and PB. And yeah, that's what I did there. So yeah, same as above, same as above. So now we're going to do a mass balance around node B. So basically, this W is the objective that we're trying to find, and we know all of the pressures at points 1 through 6 in terms of PA and PV. So we can say that the flow rate here, the flow rate out of the point B here equals W, and that flow rate equals the flow rate of 5 to B plus 4 to B plus 6 to B. So yeah, that's kind of what we do. So yeah, so W times these terms, which is just the inverse of like these outside terms. So you're basically just dividing out these terms and bringing them over to the other side to isolate the pressures. So it's just the pressures by themselves. So yeah. The mass flow and then dividing out those terms. And then that equals all of the inlet pressures, which is P6 minus PB, which is 6 minus B, and it's going to be 5 plus 5 minus B plus 4 minus B. And since we know all of those pressure, all of these pressures in terms of PA and PB, we can solve for the total thing in terms of the PA and PB. So yeah, that's what we do. We have all these pressures. We convert these P6, P5, P4 into PA and PB. And you'll notice all P6, P5, P4, they're all the same definition. And if you do this balance around node A, it'll be P1, P2, and P3 that are in the balance. And it will be this definition here instead of this definition. Obviously, that kind of is pretty self-explanatory, but I figured I'd say it. So now we're just we are just simplifying this to this, and then we multiply back over all these terms so that it has all of the pi, the 8 over mu L, the r squared in the row, like the original equation, but with different pressures, obviously. But yeah. So going back down. So yeah, just take the 6/5 out of the parentheses in here, and 6/5 divided by 8 equals 3 divided by 20, which is the answer to the problem. So yeah, if you have any answers about this or questions about this problem, or questions about any other problem that are like the B section problems in this book, feel free to ask. Preferably questions in the first 3 chapters of each section I know more about, but I've done some other problems outside of those sections. So if you want, I can try to help you with that. But yeah, have a nice day. Bye-bye.